Circularity applied to a cone. Tolerance zone boundary by two concentric circles similar to cylindrical surfaces. The boundary diameters change according to the location on the cone axis, and distances between the boundaries is specified value, and circularity only controls the circular cross-section. No effect on cone angle or size limits. And the feature control frame is attached with a leader. Circularity applied to a sphere. Control achieved with circularity tolerance is not well defined by the national standard. So the direction circular elements applied, not stated, assuming in all directions relatively conservative, and whether circular elements are located, where they're located in relationship to the sphere is unknown, but the form tolerances are not location tolerances. And notes should be added to explain the requirements, and feature control frame is attached with the leader. Cylindricity tolerance. It's applicable only to cylindrical surfaces like shafts or holes. Cylindrical surface exists where all points are equidistant from the axis. The feature control frame includes the geometric characteristic symbol and the tolerance, no diameter, MMC or LMC symbol, tolerance zone bounded by two concentric cylinders radially separated by the tolerance value, and combination of circularity and straightness tolerances are combined in this form tolerance. Cylindricity established from size tolerances. And the cylinder diameter dimension establishes MMC perfect form boundary, perfect cylindrical boundary, and cylindricity variation permitted by departure from maximum material condition. So the maximum cylindricity variation limited by the amount of departure from maximum material condition. So if you're closer to least material, you have more bonus. And size tolerance limits maximum cylindricity variations. And the size variations are not required to be centered on a MMC perfect form boundary. Cylindricity tolerance and size tolerance. So cylindricity tolerances are applied to control variations tighter than permitted by the size tolerance. The size of one boundary established using the produced feature at each cross-section. Two approaches to determining which boundary provides the best result. Cylindricity tolerance value is the radial distance between outer and inner boundary circles, and cylinders of any size provided they are separated by a tolerance value and within size limits. Form applied to a limited area. Small form tolerance limited area for feature with larger form tolerance across the rest of the feature. Supplemental geometry shows a limited area of application of the model, so sometimes you can put from point A to point B, or you actually have a hatch zone with a note that denotes the area that the tolerance applies. That's an example of supplemental geometry. Associativity between feature control frame and supplemental geometry is required. And chain line shows a limit area applicable to an orthographic view. And dimensions apply to the chain line anywhere geometry features do not establish limits of application. All right, that's it for this presentation and summary in this unit. You learned how to correctly draw and apply form tolerance symbols, complete feature control frames, and use material condition modifiers. You explored how limits of size influence form control and gained hands-on experience applying and interpreting straightness, flatness, circularity, and cylindricity tolerances. Additionally, we discussed virtual condition calculations and how size and form tolerances interact, particularly under rule number 1. By mastering these concepts, you were able to define precise tolerance zones and improve the functionality and manufacturability of mechanical components. In conclusion, by the end of this lesson, you were able to draw symbols for form tolerances, complete a feature control frame to specify a form tolerance, and properly apply material condition modifiers on the tolerance, explain the amount of form controls established by limits of size, apply a straightness tolerance to control surface elements, and show the interpretation of a straightness tolerance. You also applied straightness tolerance on a feature of size to control the derived median line and show the interpretation of the straightness tolerance. You've also explained and calculate virtual condition for a regular feature of size that has a form tolerance applied to it, and explain the interaction between size tolerances and form tolerances in regard to rule number 1. And we applied a flatness control to a surface and show an interpretation of the flatness tolerance zone. Applied a flatness tolerance on a feature of size to control the derived median plane and show the interpretation of the flatness tolerance zone. We applied circularity tolerance and show the interpretation of a circularity tolerance zone. And we applied circularity tolerance and show an interpretation of the cylindricity zone. This is the end of the lecture for Unit 5. Catch you on the next one.